Hello everyone, welcome back to our geometry class. Today we are going to start talking about our very last unit, Unit 7. And in this unit, we are going to talk about some 3D objects. The very first lesson, we are going to introduce some terms, some names of 3D objects, and the bigger topic is going to be about volume. So, before we start the lesson, the very first thing when you check the title of this unit, probably you will ask, what is 3D? What is, sometimes you probably hear people talking 2D. And what does that mean? So no matter 3D, 2D, D here is actually stands for dimension. So sometimes 2D is like a flat shape. So sometimes if you hear people talking, when we see a triangle, a square, a circle, all this kind of shape is like a flat shape. And however, for 3D objects, instead of being flat, it look like a box. And so for different shapes, of course, they have different different looks. But everything here for 3D objects, the biggest difference between 2D and 3D is 3D can hold something. It's like a box. It's called always can hold something in there. So that's why in 3D objects, instead of talking about area, like 2D shape, we are going to talk about the volume. It's talking about how much stuff it can hold. Okay, so next, we are going to introduce some terms about different kind of 3D objects. As you can see in this slide, we have the general 6 types of the objects we often use. Of course, 3D objects actually have more than these types here, but oftentimes is we always use this one, so I just leave them here. And as you can see, the blue text is their names. And for example, the first one we call cylinder. Is like a water bottle, or sometimes we put jar. We put stuff in the jar, it looks like a cylinder. And rectangular prism is one like a paper box. For example, when you purchase something through Amazon and when you get a package from them, it looks like a rectangular prism. This one is actually, we definitely always see this in our life, like when you play basketball, soccer, all this kind of we call sphere. However, one thing I want to remind you is when you cut the sphere into 2 halves, the half of the sphere is not like a half a circle we call semicircle. You probably wonder, is that called hemisphere? No, the half a circle is actually called hemisphere. So this is half of a sphere. Okay, so this is something you need to be careful that different terms probably can maybe confusing. Hemisphere, half of sphere. This one is a pyramid. As you can see, the bottom space here is actually a square. So different type of the pyramid might have different type of the different shapes on the bottom. Sometimes can be a triangle, sometimes it can be a pentagon or even octagon. All this kind of can be described as one type of pyramid, but generally speaking, the one with a square base is the one we always talk about. This one is a cone. And this one you probably see like a birthday hat, or even when you order the ice cream, sometimes we just put ice cream in the cone. So it is a cone. And this one, as you can see, is like a prism, and the top and bottom they have a shape as triangle. So that's why we call triangular prism. Very similar to rectangular prism. The bottom and the top they have a rectangle as a shape, and this one has a triangle. So this is called triangular prism, and you can always see this sometimes in the different kind of packages have this kind of objects. So as I mentioned, besides introducing the name of these 3D objects, the other thing we need to spend a little bit longer is to talk about the volume of the 3D objects. So it's definitely not your first time to hear the volume. You'll probably listen to this word in physics too. So the volume is always telling us how much the 3D objects can hold. For example, if you love cooking, you probably, when you check the recipe, or you love baking, when you check the recipe, it's always telling you how much flour you need to put in there, how much milk you need to put in there. And sometimes we will say it's 1 cup or 2 cups, or sometimes we say this is 6 ounces. All this kind of unit and description, the measurement is actually talking about the volume here. And also even for example, when you drink the milk, or you even drink the juice from the box, sometimes you listen to the words of that. It's actually related to the volume. It's talking about how much stuff is related to there. Of course, in the future, when we introduce another word which is called density, you will discover more relationship between the volume, the weight, and the density. But today, our focus will be the volume, is how much space inside the object. Okay, so before we come to this slide, you probably wonder, then how do we find the volume? Is there any thing we can follow, or any formulas we can use? So luckily, we do have formulas here. You can see this kind of formulas are provided when you take the regions. Of course, there's no regions right now, but these formulas are provided, and you can see the names of the shapes are provided, and V stands for volume here. So we're going to spend some time to actually look into this formula and check what are the things we actually look at here. So for example, when we look at the cylinder, as you can see, the formula is pi r squared h. So let's check. R clearly stands for radius. So if we need to find the volume for the cylinder, we definitely need to know the radius, and height meaning how tall of the cylinder. So this is actually talking about the height. So in order to find the volume of the cylinder, this is definitely the measurement we need to use. And also, let's check the very first one. The very first one is called a general prism. So you may be wondering, what is general prism? The one you just introduced is actually no such thing. General prism, as you can see, rectangular prism, triangular prism, everything here, as long as we use prism to describe it, we can use this formula. But there's one thing you need to be very, very careful about, the capital B here. As you can see, this is capital B. So this capital B meaning base area. What does that mean? That means I need to know how much, what is the area for the base part, and then we times the height, then we can figure out the answer. So one thing we need to remind you, for example, let's check the rectangular prism. The base, we consider the two shapes, they have the same shape, like this is a base, right? This is going to be a rectangle. So that's why, since it's a rectangle, we can use length times width to find the base. And then we just need to find how tall for this object, and then we just times the height for that. So the height is actually same as the other formulas here. But there's one thing you need to be careful when we work on the triangular prism. So when we do the triangular prism, one thing I want to remind you about the base area and the height. Let's check this shape here. We know this is a triangular prism, right? When we put like this way, we definitely know the base is the triangle. And so we need to find the area of the base, then we times how tall for this triangular prism. Be careful, this height is talking about the distance between these two triangles. So that's why we can easily use this one. But there's one thing I want to remind you. The common mistake we might make about the triangular prism, again, as I mentioned, it's going to base area times height. Sometimes students might think this way. As you can see, I don't know if you like this type of chocolate, but this is definitely the package we can see here. Sometimes might wonder, oh, the base area is going to be the base about the bottom shape here. It look like, probably a triangle. So I'm going to find the triangle on the bottom here. And then I just, measure how tall for this distance. So this is going to be the height. So this is actually the mistake I'm going to address today. So later, in order to help you to understand this better, we are going to practice several examples here to address how do we find the volume. And one of the things we are going to address is to avoid this kind of mistakes. So we are going to address how do we find the height of this triangular prism and how do we use a formula to find the volume correctly. So I'm going to see you in the second video about those practices, and hopefully after those practices you will definitely have a better understanding of how to find the volume for different kind of objects. Okay, see you soon everyone in the second video of the practices.